Hey everyone, my name is Fan Yang. I'm the technical marketing engineer for the Cisco CSR1000V. I have a lot of questions and asks from the customer, like can we do a deep dive and what is the best practice for the Transit VPC? Today I'm going to talk about those, which including networking part and also the DevOps part, like automation, how do we do Lambda, how do we troubleshoot. And by the way, I just got my certificate for the AWS Solution Architect Associate, so that's why I put on my slides. Okay, so this is today's agenda. So I'm gonna do a deep dive. It's around 20 minutes, and then the best practice is about another 20 minutes. If you are interested in the best practice, I suggest you just skip the deep dive and go to the best practice. So this is the design we have, and I'm not going to spend a lot of time on this. Everybody know what is the Transit VPC. You just create an aggregation layer in your AWS network, and then it's going to interconnect your multiple spoke VPC together, and also your on-prem network. So that's just the high-level overview of what is the Transit VPC. Now let's take a look inside the Transit VPC. I mean, in the VPC specifically, because there the customer asks, okay, what are the components that within that VPC and how that has been set up to do the routing, to do everything. So if you look at the Transit VPC itself, you are start finding, okay, there are two subnets and they are put in different AZ. Because AWS doesn't support the subnet across different AZ, so if we want to support HA and we put two CSR in different AZ, we also need to create two different subnets. So that's probably when you deploy the Transit VPC, you will see there are two subnets, or that are the same two subnets you defined in the CloudFormation template. And the one route table is associated with those two subnets, so they can share the same routes. Well, basically, there is one default route in that route table, which is pointing to the AWS Internet Gateway. So yeah, there's Internet Gateway also created and is attached to the Transit VPC, and in the route table, which is on the VPC router in the AWS infrastructure, a default route is pointing to the Internet Gateway. The reason to have an Internet Gateway and the default route in the route table is the CSR are using the elastic IP to build the VPN to the other VGW, which is a different spoke. And because this is an EIP to another public IP of the VGW communication, and those public IPs are managed by AWS, so actually it will write over AWS infrastructure or their backbone. So it will never goes out to the internet and comes back. So it's pretty stable and the throughput is pretty good. And in the CSR, there's only one interface, so you will only be able to see 1 gigabit 1, and it has and inside of the CSR there's also a default route, and it is pointing to the first IP address of that subnet, and that will be the VPC router, which is AWS infrastructure. So which means the CSR will always send the packet to the VPC router, and then the VPC router will do the routing for you, but basically we are just relying to do the overlay. And once the overlay has been built, the CSR will take over the routing control. And in this topology, probably you also find out there are direct connect. I put here as well. And there are two different ways to connect direct connect. One is attached VGW, the other one is detached. And I will talk about what are the pros and the cons to do each and in a later slide. But basically, if you have your attached VGW, which is attached specifically to the Transit VPC, the traffic flow will be from the CSR, goes to your VPC router, goes to the attached VGW, and then goes to the direct connect. If you have a detached VGW, which the CSR will talk to the VPC router, and then it will talk to the IGW, and then goes to the detached VGW because they are doing tunneling, which I will cover that in a later slide, and then it goes to the direct connect. So I highly recommend you come back to this page after I talked about the direct connect part, which is in the later slides. And hopefully this make you feel comfortable understanding what inside of the Transit VPC and how that the routing has been set up. And then the other question is, what is outside of the Transit VPC? How do we do automation? What are the components you are using for this solution? So I make this topology easy to understand. So there's a Transit VPC in the middle. On the bottom, there's your on-prem network. You don't have to worry about that. On the up area, there's a spoke VPC, and there's VGW in the spoke VPC, which will be mainly doing IPsec tunnel, goes back to the CSR in your transit. That's kind of the networking view, right? If you look from a DevOps view or the developer view, what are the components you are using? So we are using two Lambda functions, will be the VGW Polar and the Cisco configurator. We are leveraging Amazon S3 bucket to install all the metadata information, which will include what is the CSR instance ID, what is the CSR public IP, what is the CSR username, what is the CSR key I should use to log into the CSR, and what is the BGP AS number I should use. So those metadata information are stored in S3 bucket, which is very important. And because we want to add another layer of security, we also enable the data at rest encryption. So that's also recommended by Amazon. Every sensitive data you store on their storage site, you can always enable the encryption at rest. So we use AWS KMS key, so it's the key management service, and we choose the key to encrypt the S3 bucket. And for those two Lambda functions, which is VGW Polar, so basically it pulls the VGW status in that account to see if there's a matched tag. And the tag you define on the CloudFormation template when you spin up the whole thing. If it finds out there's a matched tag, it's gonna create a S3 file under a specific folder, which by default is the VPN config under the S3 bucket. And then that put event under the S3 bucket will trigger the Cisco configurator, which is another Lambda function. And the Cisco configurator basically will read that file which containing the VPN connections. It will read the metadata information in the S3 bucket to know what are those two CSRs I need to configure, and then log into the CSR with SSH, push the configuration, and the tunnel will be built. So those are the components which we used to build the automation of the Transit VPC. And for you probably ask, okay, how do I enable across accounts? Because if the S3 bucket is encrypted by the KMS key, how do my other account access the S3 bucket? So if you think about the mechanism, automation mechanism, how it works is basically the VGW pull the VGW Polar, pull the status of VGW, update the file in the central place, which is the S3 bucket, then kick off the Cisco configurator. If you have another account which is representing another spoke, you have to deploy another VGW Polar in that spoke. And by deploying the template, the spoke template, you will be able to deploy that VGW Polar. And you also have to enable the VGW to be able to access the S3 bucket, which is stored in that central account, which is your Transit VPC account. You have to also make sure the KMS key can be accessed by another spoke account. And we all have a very well documented documentation on the AWS side, so you can take a look at that. But basically, that's something happening under the hook. And that VGW running in a different account has a matched tag, and then it will trigger the VPN configuration upload file to the S3 bucket, which is stored in your central account, and then it's gonna trigger the Cisco configuration. So you can think the Cisco configurator only resides on your Transit VPC account, and the VGW Polar will be at different spoke account if you are running multiple accounts. So that's basically how the automation works. And if you want to change the script, you can just download the Lambda function, upload it again, but you have to make sure you follow the same way as we designed. Okay, so back to the network part. And a lot of customers ask, okay, why do I see so many VRFs on the CSR? That is because we want to build the traffic segregation capability and offer this to the customer. If you look at the Transit VPC, you probably have multiple spoke VPCs, and those multiple spoke VPCs might be your account or might be your partners. And sometimes you just want to connect to a partner so they can access your data center, but without having access to your spoke VPC, right? I have a dev VPC running and I have a partner. I just want them to authenticate with the Active Directory on my data center, but I don't want them to access my dev VPC. There's no point to allow that access. So you can use the capability we're building. So basically, there will be multiple VRF created, one VRF per spoke, and then we are using the BGP VRF route leaking. So everybody can talk to everybody by default, because every VRF on the CSR are importing the same root target and exporting the same root target. If you want to control the route leaking, you basically say, okay, I don't want my partner C to access A and B, so C can just import a different route target, and that will allow that will make C cannot access A and B. So the other question I got a lot is, how do I connect to my on-prem? So let's assume this is a VPN connection, and then you need to create an on-premise VRF. You basically have to follow the same VRF mechanism, BGP routing mechanism we implemented. You basically have to create an on-premise VRF. You have to make sure it import and export the same route target with other VRFs, and then you either create a tunnel goes back to your private data center over the internet, or over the direct connect, or you use other ways to connect. But basically, you have to follow the same mechanism, including the VRF and also the BGP part. HA. Customer has question, okay, I have two CSRs in different AZ. Do I have to set them up as HA mode? You know, we have the HA, like CSR will monitor the other status and do a REST API to change the route table. That's not required in the Transit VPC. It is only required if you have your VM that's running in the Transit VPC. Assume there's no VM running in the Transit VPC except the CSR, and then you have your VGW running at the spoke. The VGW will establish two tunnels, goes to CSR1 and CSR2, and then if one tunnel fails, it will switch to another CSR. So the VGW will become the point which will hunt the HA. And because the VGW doesn't support active today, it only supports active standby, and it will pick one of the CSR as active, kind of randomly. So there is a chance your spoke A is using CSR1 as active, your spoke B is using CSR2 as active. So from our perspective, from the CSR perspective, we are forwarding traffic at the same time. So it is an active solution, and each CSR can do up to 5 gig, so total should give you up to 10 gig throughput. And probably you have the question, okay, how do I make sure the spoke use the CSR? I want to use CSR1 as active, and I will talk about it in the best practice section. Having said that, the Transit VPC build an overlay network, and each VGW actually is a logical concept. There are two endpoints running underneath to provide HA, and so in this topology, you will be able to see 4 tunnels, and the CSR will be acting as a custom gateway. So each CSR will have 2 tunnels. Total is going to be 4 tunnels. And if you add another spoke VPC, another 4 tunnels will be created. So that's how the overlay network looks like. And you can do a show run interface tunnel on the CSR to see what is the destination IP, and actually that will be the public IP on the VGW. Also, you can go to your VPC page, which is running here. On the VPN connections, you will be able to see those 2 VPN connections, which goes to CSR1 and CSR2. But actually, each connection has 2 tunnels. So that exactly tells you I only have 1 VGW, but actually I got 4 tunnels. It is done because I shut down the CSR to cost saving. But basically you can see this is the tunnel outside IP address, which will be the VGW side public IP address. The inside IP address will be the local IP address of the tunnel, and then you can check the other end on the CSR as well. Multi-region deploy. The Transit VPC itself support multi-region, which means if you have a spoke that's in a different region, it can connect back to a Transit VPC. But probably if you're running a lot of VPCs in a different region, you don't want them to talk to each other and traverse the other region, right? So it's suboptimal path. You probably would start to think, okay, can I deploy 2 sets of Transit VPC, and each set of Transit VPC while acting as a regional hub, and if they want to talk to each other, the hub talk to another hub to talk to each other. So this is the design I've seen customer deploy a lot, or recently come up a lot. You have a US West, you have the first set of Transit VPC, you have the US East. Make sure you choose different spoke tags, because as I mentioned before, all the automation scripts are based on a tag. So by default, if you don't change the tag, it's gonna be transit spoke, and then the value is true. The Lambda function might get confused, so your spoke VPC that's in the left might be connected to the transit VPC in the right if you are using the same tag. Make sure you use different tags, and also make sure you use different BGP ASN number for the CSR in the transit, because you always want to troubleshoot so you know what are the AS paths coming by this route. So that's basically how you do multi-region, and then you do the tunnel between the CSRs that sit in different transit VPC. And this will also write over AWS backbone if you are using the elastic IP. And later, if AWS come out with a cross-region peering, then you can just create a peering between those 2 transit VPC in different regions, and then we create another overlay. So this is pretty scalable design. Let's talk about how to connect to a direct connect. As I mentioned, there is a detached VGW. In this case, you have a VGW which are terminating the direct connect, which has been assigned by the virtual interface function, the virtual interface, the VIF, and then the CSRs are talking to that VGW through an IPsec tunnel. And because the VGW is doing the IPsec, the throughput is limited to 1 gig today, and I think Amazon is also improved that throughput. But basically, if you have a 10 gig pipe, you will only be able to leverage the 1 gig connection. If you have a 1 gig or sub 1 gig, I think that's totally fine. And this design, the benefit of this design is leverage the current Transit VPC automation. You just treat this VGW as another spoke. You add a tag, the tunnel will be created, routing will be done. So it's very clean to set this up. But the downside is you can only do 1 gig from your transit back to on-prem if you have a pipe that's bigger than 1 gig. And there are 2 BGP connections as I draw out here. The other way to do that is called attached VGW. As you can quickly find, the difference is this VGW is attached to the Transit VPC itself. And then, because it is attached, this VGW actually will advertise the routes of the Transit VPC itself to the on-prem data center. and then your ASR on the data center side or any router firewall on the data center side can talk to the CSR directly. And then you can build a tunnel between the CSR and your ASR, and then your VGW will just do routing, no IPsec, so it's transparent. Then you have the option to do encryption. Then you go with the IPsec tunnels from CSR to ASR. If you don't need encryption, just go with GRE. So, and in this case, because the VGW is only doing routing, so it's not capped to 1 gig, you should be able to leverage the 10 gig pipe. And each CSR support 5 gig today, so the total will give you 10 gig throughput to utilize the full pipe of your Direct Connect. The downside of this solution is either you have to set it up manually, or you have to use sort of automation. The YouTube link I put in below is I set it up manually. I walk you the step, how do you create the tunnel, how do you create the VGW. It's about 30 minutes video, and you should be good. I'm also working on automation, and also on automation video, which will be published later, hopefully later before Thanksgiving, and then I will share that video as well. Okay. As you probably see, my title is Technical Marketing Engineer. I have done a lot of presentation to the customer, like how do they design the network, how do they leverage the CSR to design a scalable network in the cloud, and also once they deploy the CSR, how do they use the CSR, how do they do this, do that. So I think I probably have been on thousands of, not thousands of, but at least like 600 customer calls already. And those are the questions comes up a lot, including like the support type of questions, including kind of operation questions, design questions. I'm gonna cover those one by one. So the first one is CSR dropping packets. Okay, so you need to make sure the CSR is running at the license throughput. And we have bring your own license, and we also have the hourly. The easiest way to tell which license option you are on is just do a show license all on the CSR. With bring your own license, you can see there is a feature. So it tells you are using which technology pack. So you are using AX 2.5 gig. And the license state says active in use. Sometimes it will say active not in use, which means you are in a wrong technology pack. So how do you fix that? You do a show version. It will tell you which technology pack you are at now. If it's different than the license technology pack, you have to go with configure terminal, license boot, change to the correct matched technology pack to your license file. Then save the configuration, reload the router. When it comes up, make sure it shows active in use. The next step to make sure the CSR is running at the correct throughput is show platform hardware throughput level. And this will tell you what is the throughput level you are running. If you see the number is different than the license, you have to go to configure terminal, do platform hardware throughput level, MB, and then put the correct. And you have to make sure it show up the same throughput as on the show license all. And hourly is pretty easy to show license all. It doesn't give you too much information. But if you do a show platform hardware throughput level, it will show up it's a 200 gig, which is the maximum. It's an uncapped license, just to let you know. So it doesn't throttle you from a license perspective. How much you can go is basically based on instance. And then there is another useful command you can use to show what is the reason the CSR are dropping packet. This is IPv4 non-adjacency, which means probably some neighbor is not forming correctly, so you see a packet job. If you see a tailed job, that means you exceed the maximum license of the CSR. So probably you have to go either with a larger instance type, or you have to upgrade your license. Second one, I noticed VGW tunnel status is down on the AWS console. And then you probably have the subsequent question. How do I make sure the Lambda script is working? Because sometimes we do too much things and you think this is like black box, black automation. And I can let you know how do you do that. So first, I recommend you go to the CSR first, check the tunnel status on the CSR. The VGW side might be a little bit delayed. If the CSR side looks fine, everything is fine. If the tunnel on the CSR is down, or there's no tunnel has been configured, even if you give the tag to the VGW, check if the CSR has the correct configuration pushed. If it has the configuration pushed, the tunnel should be up automatically. And just to let you know, the CSR security group doesn't need inbound rule for UDP 500 and 4500. That is because the CSR is the IPsec initiator. So CSR will do outbound. And because the security group is more like firewall, so the return traffic will be allowed. So you don't have to put inbound rule. If the tunnel doesn't come up or doesn't have the correct configuration, it means the Lambda function has at least one of the following problems. The first is the VGW, as I mentioned before, how the automation works. The VGW poller cannot pull tag or run tag specified on the VGW, which you can figure it out very quickly. The other part is kind of tricky. Cisco configurator cannot push configurations to the CSR. So now you have to go to the CloudWatch logs to identify the root cause. Let me just show you how to check the logs. Okay, so this is the Transit VPC I just deployed. Yeah, so Thanksgiving is coming, so I just name it as Thanksgiving. And then you can click the outputs. So it's going to tell you what are the resource, what output is put here. Like what is the tag? I put a Thanksgiving tag here. What is the attribute bucket I talked about? What is the spoke tag? So those are the information you can find in the output. If you click resource, you will be able to find the Cisco configurator. The Cisco config. This is the Cisco configurator, and you will be able to find the VGW poller as well. So let's go to the Cisco configurator. If you click this one, it's gonna redirect you to a Lambda function, which is here. And then if you click on monitoring, you can see I have 0 triggers because I didn't add a spoke yet. And then if you want to see the logs, you can see view logs in CloudWatch. Let's try to find a cloud formation or the Transit VPC that has been triggered. Let's go back to here. Take a look at my DX part. Okay, now let's take a look at this one. If we go to the configuration, okay, I cannot do it here. Let me just go to the Lambda. And then we can just choose DX, this one. And then the triggers, correct, monitoring. Yeah, it only show up the last 24 hours, but I know I have some spoke connected. If you do the vlogs in the CloudWatch, it's gonna redirect to the CloudWatch, and those are logs. As you can see, I have it running for or close to 6 months. And then let's click one of, and you can see they are logging come out of the CloudWatch log, and you are able to see it's starting to download the private key, and then it's starting to connect to the CSR1. It's connected, it's pushed the configuration, and then it will connect to this. And it also tell you create a VPN with tunnel ID 1 and 2, and those are the VRF I mentioned for each spoke. Yeah, so this is the place you want to look for if you don't have the configuration pushed to the CSR or the tunnel is still down on the CSR, and you might be able to see some error message and you need to troubleshoot based on those error messages. Okay, let's go back to the slide. The next part I want to talk about is how do you make sure you want to choose one of the CSR for your specific spoke. And this is very useful if you are running some stateful features on the CSR, like the zone-based firewall, or if you enable the IPS, as I put in a different video, how to enable IPS. And by default, the CSR1 and CSR2 are forwarding traffic. If you don't enable this preferred tag, you probably will end up with an asymmetric routing issue. So the packet may go to the coming packet may go to the CSR, the return traffic may go to another CSR. If you are running zone-based firewall, the packet will be dropped because half of the conversation doesn't make sense, right? So what we offered on the CloudFormation template is there's a preferred tag value you can define. And with that preferred tag, you can just add to the VGW, and then you give the value as CSR1, then the CSR1 will be preferred. If you change to CSR2, the CSR2 will be preferred. In this case, we put to CSR1, and let's take a look at what is happening underneath. So basically, after you put the tag, when you build the connection, the automation will push a BGP AS path prepend to the other CSR. So the VGW is going to learn the routes from both of the CSR, but the routes from CSR2 has a longer prefix. And based on the BGP path selection, a shorter prefix will be preferred. So it will choose the CSR1 as active and CSR2 as standby. And this preferred tag will only work when you add the connection. If you have the connection already, then and this tag will not trigger the Lambda function. So just make sure you add the tag when you build the connection. Next one is how do I do a maintenance on the CSR, for example, the version upgrade. So we support inline upgrade from 16.5.1b version and onwards. So it will be the same process as upgrading a physical iOS XE router. So you just upload the bin file to the CSR, you change the boot to pointing to that bin file, you reload the router, the CSR comes up with a newer version. If you are running the version below 16.5.1b, this is not supported. You have to create a new CSR, copy the configuration from the old CSR to the new one, destroy the old CSR, and then make the upgrade. And as I mentioned, every automation piece is based on the S3 bucket. And there is a public IP address or the elastic IP address has been stored on the S3 bucket. So you might also, to make sure the previous elastic IP can be moved to the new CSR. Can be moved to the new CSRs. If you accidentally remove the elastic IP or lose the elastic IP, do not worry. You can update the S3 bucket with the new elastic IP. Because the automation is going to read that S3 bucket, so if you just update that IP, and that IP can be used. The only catch there is the previous VPN connection is based on the old elastic IP. So you probably need to remove all the previous connections and then just tag it back. And if you want to do the upgrade, inline upgrade, I recommend the following steps. So two CSRs are working at active. You should let one CSR stop forwarding traffic gracefully by shut down the tunnels on the CSR. Then all traffic will be forwarded to the other CSR. Upgrade the CSR to upgrade the CSR with those shutdown tunnels to the correct version and bring up tunnels. Then the traffic will be load balanced across two CSRs. redo the same on the other CSR to upgrade. So those are the steps we recommend. The other comes often is how do I manage the CSR through a private IP rather than elastic IP? Or probably you notice that you cannot access the CSR local IP from a spoke VPC. You don't see that route. That is because we are using the BGP routing part, and the gigabit 1 interface on the CSR is under a global VRF. We don't advertise that prefix into the BGP, so the spoke doesn't learn that route. So if you want to reach out to the CSR through a local IP, or you have some sort of network management system want to access the CSR with a private IP, I recommend to go with the loopback interface. And then you put that loopback interface under a management of VRF, make sure it export and import the same root target, and then it can be routed to other VRF, to other spoke, to on-prem. So those are the configurations you need to put on the CSR to make sure it can be correctly propagated. And you also have to create a BGP configuration and redistribute your loopback 0, or you can just say network that IP address as well in the BGP configuration. And then on the right side, that's my sample Transit VPC, or one of my spoke VPC, which can learn the loopback IP address from the VGW, which has been advertised from the CSR. So that's typically how you do management from a local IP address. If you manage it based on elastic IP, as long as you have the internet connectivity, that should be fine. This one is pretty interesting. So how do I control who can connect? So the VGW tag is pretty important because it's going to trigger the Lambda function which build the IPsec connection. So who control the tag, who control the connection? And then you probably have the question, how do I control who can add tag to my VGW? Probably in the same account or in a different account. How do I use different account? How do I use a single account to manage multiple accounts? That's the topic I'm going to cover in this part. So we can definitely use IAM roles to control it. It's not that cumbersome, but you need some good understanding of how IAM works. You also might find another security tools like Cisco CloudLock, which help you from a GUI-based option. So let's talk about the IAM part. These are so assume you are running across accounts, okay? Because that's the most difficult part. If you are running the same account, you just change the account number to your account number, and that's not a big deal. But let's assume you are running different accounts. And in the spoke VPC's account, you need to do multiple things. The first is you need to add a modified VGW tag policy here. And as you can see, those are the policies you need to define. And this account number is your spoke account number. That's not your Transit VPC account number. That's your spoke account number. And the VGW ID, you can just drill down to say, okay, which VGW people can add tag. If you want to represent all VGW, you can just use the star sign to represent all. And then it also need another permissions. The first permission you put is to create the tags and delete tags. So that's basically you want those people to do that. The second one is you need them to describe the VPN gateway, VPC tags, describe VPC tag, VGW tags as well. So they can list the tag first and then modify the tag. And after you create this policy, you need to attach it to a network admin user, so they can have those privileges to control the tags. For those DevOps people or line of business, they don't want for those people, you don't want them to have the control to the tag. You can create this deny action effect, and then put create tag, delete tags as action, and then you can also put a specific resource here. you can use star sign to represent all tag. Now, the first two policy has to be done to prevent other people to change the tag. But if you are running multiple accounts, spoke accounts, you have to do that repeatedly in multiple accounts, and you have to log into those accounts and do the modification, right? The other better way to do that is let's use assume role, and this can be very beneficial from a single account management perspective. So basically what you need to do is you need to create an IAM role, and that role can be assumed by your Transit VPC account, which typically is the network infrastructure account. And in this case, you're going to create the access VGW IAM role, and you're going to attach a assume role policy. And in that policy, you also specify the spokes account and also the access role, the IAM role. And also to let the Transit VPC account to access this IAM role in a different account, you need to put trust relationships. And in this case, this account will be your Transit VPC account. So those are the parts you need to put together, and you have to make sure you didn't miss anything. Then you go back to your Transit VPC account. You can log into your account with a specific user. Login with root doesn't work, and then you can do it switch role. So that's basically, you can see it here, and I'm gonna show you. Okay, so this is my Transit VPC account. Everybody knows about that, but let's assume this is my spoke account because I have a couple of VGWs running here. Okay, I have those VGWs running, and as I mentioned, you need to create two policies in a spoke account. So assume this is spoke account. Let's go to the IAM part. Let's take a look at the policy. I guess I already created, so we can just take a look. Okay, so this is policy. Those are the policies I put here. As you can see, I only allow the 21A VGW to be modified. In the meanwhile, let me go back to my VPC on the left-hand side as well. So 21A, so it's this one. Okay, and I allow other people to do describe VPC. I also have something deny. Okay, I guess I didn't create it, but let's create it right away. We can just put JSON, and we can just copy this part here. Make sure to remove the comment here. Reveal policy. Okay. Now let's put the name modify. Okay, let's create the policy. Okay, and once you create those two VGW policies, you can attach them to different users, and they will not be able to access. They will be able to access or not able to access based on the policy they have been attached. So we don't do this in the same account. Let's do the cross account. Now you have to create an assume role policy. Let's see if the policy is here as well. Okay, the policy is here. It's exactly the same I put on the slide. So basically, it allows people to assume the access VGW policy role. And then you have to create an IAM role. which I think I already created. It's called VGW, this one. And you have to attach the policy of the modified VGW tag. So that basically when people assume this role, people will be able to use this policy, which basically will allow to create or modify tag for this specific VGW. And then under the trust relations, you have to add this one. And this is your Transit VPC or your network infrastructure team managed account. You can just add another one if you have multiple. Then I will log into my network admin account, a different account. Let me go to my Chrome and let me do a logout first. Let me sign into the console. This is exactly the same account, 829. The username I put here is here. And remember, you have to log in with the IAM user, not a root account. And now if you go here, you can see switch role, and you can click this one. So this will switch you to the role that has been defined in a spoke. If we go to the VPC, as I mentioned, it gives you the way to list the VPC, but not other permissions. You will not be able to see other things, but you're able to see those VPCs. Also, go to the VGW side. You are able to see all the VGW I can see in a different account. But you will only be able to change this one. So the TS VGW-A. Let's take a look at the tag. Okay, so the tag is already here. Let's add something else. We don't have to modify the specific tag because we don't limit the specific tag modification. We basically define somebody cannot do all the tagging for a specific VGW. So let's save. Okay, it has been added. It shows up here. Let's see if we can remove it. Okay, it can be removed. Let's try this -B. Add one. Okay, it tells you are not authorized to perform this option. So that is because in here, the permissions you have only allows you to change this specific VGW. If you want added this policy to allow everything, just change this to star. Review the policy, save it, delete the old version. I don't have to maintain the old version. Check it again, allow everything, go back to different account. So one catch here, in order to let the IAM take effect, you need to log out and re-log in. So let's log out first. Let's try to sign in again. Let's do a switch role. Let's go to your VGW. Let's try this one, -B, which we cannot modify last time. Let's see if we can modify it this time. Okay, it allows you to modify. As you can see, this has been added, and you can also remove it. Okay, so I think this gives you a sense if you want to control the policy. You can either do with all or you can do with a specific VGW. But maybe I think all the star makes sense because you have no idea what other VGW people will create in future, so you cannot drill down with just the ID. But let me change it back. So I think this is pretty easy example to how to control who can access the tag and which will trigger the Lambda function, and you can just copy those parts to your IAM role. The last one I'm going to talk about is how do I delete the whole stack. Typically, deleting the CloudFormation template will do 99% of the work to delete everything. But you need to make sure the termination protection is disabled on a CSR instance The reason we have this enabled is we don't want people to accidentally delay the CSR because your infrastructure is going to break the connectivity. I think in the template, this is enabled by default, and you can disable it when you deploy the template. Just make sure you disable it before you delay the template. And then you either can just delay the template, or you can delay or terminate the instance manually. After you delay the template, you probably will get a delayed failed message at some point. It is because by AWS design, the S3 bucket cannot be delayed by the CloudFormation. And that is the S3 bucket containing all the metadata information we talked about before. However, a second delay will delay the S3 bucket. So let me show you the process. We go back to the Transit VPC running here, and I have the termination protection enabled. So how to disable? Instance settings, change termination protection. Now it is enabled. We can disable it. And then we have to do the same thing for we have to do the same thing for the other CSR. Change termination protection, disable it. Now, if we go back to the CloudFormation template, and we have an S3 bucket for that, I think it will show up here. So this is S3. Okay, so let me also go to the S3 bucket to tell you which S3 bucket I'm talking about. Okay, so VPN configs, basically this one is the metadata I'm talking about. If you open it, you can see those are the elastic IP, BGPS number, blah blah I'm using. And also the Lambda will use this private key to log into the CSR to push the configuration. And this S3 bucket cannot be deleted by the first click on the Transit CloudFormation. So let's try to delete the stack. It will take around 5 minutes, and then you will get something like a delayed fail, and I will come back and tell you the reason. Okay, now we get to the point, the delayed fail. And then if we click the events, it are telling you those event has been going on, like security group has been deleted, instance has been deleted, and then it will tell you which resource failed to delete. And that's the S3 bucket. That's exactly the S3 bucket. And if we go back here, the S3 bucket is still here, right? Because by default, the CloudFormation cannot delete the S3 bucket. It's still here. If you refresh, it's still here. As I mentioned, a second delay will delete. Okay, let's drill down to this information. It says if you want to retain the following resource and skip those resource deletion, check. So if I check that box, which means the CloudFormation will continue to be deleted, but will keep that S3 bucket. I think that's a recommended way because you probably want to revisit your information even the template has been deleted. But if you want to delete the S3 bucket, you can just go ahead to the S3 bucket place to delete it manually. So I will check, click the check. Check this, delete. Okay, it's done. Then we come back here to see if the S3 bucket is still here. So it keeps here because I said retain the following resource. If you really want to delete it, click this one, delete bucket. You have to copy this part, the name of the bucket, and then click confirm. Then the bucket will be deleted. If you try to search again, it's gone. I think that's it. It's a long video. Thanks for watching and happy Thanksgiving.